Hi guys, we're just waiting for people to roll in.
Radha, can you still see my video?
Yes.
Okay, cool.
Hi guys, we're just waiting for people to roll in. 8 o'clock, welcome. Let's give it a few minutes.
8 o'clock EST, 7 p.m. CST.
Yeah, we're working in different time zones here.
Yeah.
Hi guys, welcome.
You know what? Until we're like waiting, I can go ahead and play some music.
Yeah,
See.
good. Guys, we'll get started in a few minutes. We're just waiting for people to roll in.
Can you hear that?
Yep.
Okay.
Yeah, so let's give it a couple more minutes, maybe like 1 or 2 more minutes before we get started. Welcome.
Yep.
Okay, so okay, I think we can go ahead and get started. Hi guys, welcome. This is Introduction to Azure. My name is Radha Panchap, and I'm joined here by Dakshika, who's another Microsoft student ambassador. And so before we get started, I wanted to speak a little bit about this seminar. It's essentially on Microsoft Azure, which is one of Microsoft's public cloud computing platforms. And so I wanted to get into Azure's prominence in the industry. Azure is used across several career fields, including software engineering, analytics, and business development. And so becoming familiar with Azure will allow you to essentially position yourself as a unique candidate regardless of the field that you go into. So it's a very important skill to have. And so we're excited to show you the seminar today. And so really quick, we want you guys to sign in just so we can get a head count of everyone that's here. And so we'll give you guys a couple minutes to do that. And I can put the link in the chat as well.
Also, please use the email address that you used for RSVPing. That would really help us. Thank you.
Okay, I think we can go ahead and move on to the next slide.
Awesome. Yep.
All right, so we just wanted to provide you guys with a little bit of an introduction as to who we are. So my name is Radha Panchap, and I am a junior at Emory University studying computer science and information systems operations management. I am also pretty experienced with Java, Python, R, and SQL, and have a bit of software engineering experience with developing UI, UX, and backend development as well. I am interested in cloud computing and data analytics for career-wise, and I hope to combine it with my passion for business.
All right. Hey, everyone. My name is Dakshika. I'm currently a sophomore at Texas A&M University, majoring in computer science. I have experience coding with C++, Python, JavaScript, and I also have research experience in data analytics. Most of my personal projects have been based in web development, so I enjoy doing that as well. In my free time, I like to write blogs and play the keyboard. And there's my LinkedIn in case you want to hit me up. All right, so before we start learning about Azure, let's first quickly determine how much we already know. So for this, I have a fun Kahoot activity planned for us. Now, if you've never played Kahoot before, it's a fun quiz-style game where you earn points for answering questions correctly. Just one important thing to note here is that the faster you answer the question, the higher your score will be. So I'm gonna start the game here, and you all can go to this link, kahoot.it, on your mobile devices or your laptop and enter this game pin to join the Kahoot. And I'm gonna wait for everyone to join, and then we're gonna start the game. This music is the only reason I like Kahoot. Oh my god. This music is awesome. I like the to do and hello world. Wow. Let's see, how many people do we have?
So there's 33 people in the meeting and 23 have joined so far. There might be people who maybe don't want to do the Kahoot, and so that's fine. Like we'll wait like 2 seconds and then we can get started.
All right, I'm gonna wait 1 more minute. Anybody who hasn't joined, go head over to kahoot.it and put the game pin inside.
Okay, I think we can get started.
Yep, looks like no one else is gonna join, so let's go ahead and start. Welcome to Fun with Azure, and I hope you have fun playing this Kahoot. The first question is, what is Microsoft Azure? Two people, get your answers in. Oh, yes. So it's a cloud computing service to manage applications, and we're going to learn more about this. All right, let's go to the next question. But before that, the leaderboard. Okay. These are our star performers. Next question, true or false? Cloud computing resources are terribly expensive. Any Minion fans? They are actually relatively cheap to use. All right. Ooh, positions have changed. Okay. Which of these can you do with Azure? Yep, you can do all of them. Wow, everyone in the audience is like quite aware of Azure. Okay, let's see the leaderboard. Ooh, Prisha is at the top. Let's see. True or false? If my app goes down in the United States, it's gonna go down all over the world. One person. All right, I think we have everyone else. Yep, the answer is false. So, okay, Prisha is maintaining her position. Which of these is not a cloud service model? This can be a bit tricky. Ooh, okay. Well, we're going to talk in depth about these cloud service models, so don't worry about this one. Let's see, have the positions changed? Ooh, okay. Jen is at the top. True or false? I can't start working with Azure until I buy the entire suite. Everyone's quick.
I love this meme.
Okay, let's skip this. Oh, wow, everyone got it correct. Great. All right. Last question. This workshop seems super exciting. Yay. Okay, let's see. Awesome. Well, I'm gonna stop this. And I'm going to stop the screen share. Radha, you can take it away from here.
Okay, can you guys see this?
Yep, we can see it.
Okay, so for today, I wanted to get into the table of contents. So today we'll be providing a brief overview of Azure's technology. In our first section, we will give you a high-level overview of cloud computing and Azure. In our second section, we'll delve deeper into fundamental Azure concepts. And in our final section, we'll go over core architectural components of Azure. And so I just wanted to pitch this question to the audience. What do you think of when you hear the words cloud computing? And so feel free to use the chat and even like unmute yourselves if you would like. Yeah, so I see some responses: increase in speed, data storage. Yeah, so we'll be getting into a little bit of a definition as to what exactly cloud computing is and sort of help you guys to understand more about cloud computing and how it relates to Microsoft Azure. And so what is cloud computing? And so cloud computing is the delivery of computing services over the internet, which is otherwise known as the cloud. And so these services can include servers, storage, databases, networking, software, analytics, and intelligence. It offers faster innovation, flexible resources, and economies of scale. Cloud computing is essentially a way to rent computer power and storage from someone else's data center. So what does this mean for you? You don't need to have a PC with a million gigs of memory. Oftentimes, people look for computers with tons of storage. With a cloud system like Azure, you can borrow space and store files essentially, and so this can save you a lot of money in the long run. And so I'll hand it over to Dakshika to talk about why cloud computing.
Awesome. Thanks for the introduction, Radha. So when we did the Kahoot earlier, we saw a question which asked that if your app goes down in the United States, does it go down all across the world? And the answer to that was no. And this is a really neat example of the advantages of cloud computing. And of course, there are a lot more examples of advantages as well when compared to a physical environment. So it is important that we understand these properly before we actually start learning about Azure, because this will help us better grasp the functionalities of Azure. So we can go over to the next slide, Radha.
Yeah.
Okay, so why should we use cloud computing? What exactly does it have to offer, right? So when applications and services are hosted on the cloud, there are multiple advantages available not only to us as developers, but also the users. So with high availability, for example, cloud computing ensures that users have continuous experience with no apparent downtime. You get the flexibility to scale your applications as the traffic increases. Now, the scaling can happen either vertically or horizontally. So when it happens vertically, it means that you increase compute capacity by adding RAM or CPUs to virtual machines. And when you scale your app horizontally, you essentially are able to add instances of resources such as, more virtual machines to your configuration. Cloud-based apps can also be auto-scaled to always have the resources that they need, and this feature is known as elasticity. Agility, on the other hand, allows you to deploy and configure resources quickly as you make changes. You can deploy apps and data to regional data centers across the globe, ensuring that your customers always have the best performance in their region. And lastly, in the event of a disaster, your data remains safe thanks to cloud-based backup services, data replication, and geo-distribution. So cloud service providers operate on a consumption model. You can see on the right side of the slide. And what this means essentially is that the end user only pays for the resources that they use. Now, there are a lot of benefits of using a consumption-based model, which include but are not limited to the fact that there are no upfront costs. there is no need to purchase infrastructure that the users might not use. You pay for additional resources only when you need them, and you stop paying for resources when you no longer need them. Cloud services are also categorized as OPEX. So what does this mean? Now, expenses can be of two types. First is capital expenditure, also known as CapEx, and this refers to the upfront spending of money on physical infrastructure and then deducting that upfront expense over time. So essentially, the upfront cost from CapEx has a value that reduces over time. Operational expenditure, or OPEX, on the other hand, means spending money on services or products now and being billed for them now. So you can deduct this expense in the same year you spend it. There is no upfront cost since you pay for a service or product as you use it. So essentially, to summarize, CapEx requires significant upfront financial costs as well as ongoing maintenance and support expenditures. On contrast, OPEX is a consumption-based model, so you are only responsible for the cost of the computing resources that you use. So if you've ever explored cloud computing before, you've probably come across the acronyms IaaS, PaaS, and SaaS for the different cloud service models. What these models do is that they define the different levels of shared responsibility that a cloud provider and cloud tenant are responsible for. So let us go a little deep into all of these service models and understand how exactly they work. So Radha, you can go to, okay, awesome. So the first one is infrastructure as a service. And I like to think of this cloud service model as being closest to managing a physical server. So essentially, the cloud provider will keep the hardware up to date, but the operating system maintenance and network configuration is up to you as the cloud tenant or as the developer. So an example of this would be Azure virtual machines, which are fully operational virtual compute devices running in Microsoft data centers. And an advantage of this cloud service model is rapid deployment of new compute devices, because setting up a new VM is considerably faster than procuring, installing, and configuring a physical server. The second category is platform as a service. This cloud service model is a managed hosting environment. So what happens here is that the cloud provider manages the virtual machines and networking resources, and the cloud tenant, which is you, deploys their applications into the managed hosting environment. So an example of this would be Azure App Services, which provides a managed hosting environment where developers can upload their web applications without having to worry about the physical hardware and software requirements. So the last category is software as a service. In this cloud service model, the cloud provider manages all aspects of the application environment, such as virtual machines, networking resources, data storage, and applications. The cloud tenant, which is you, only needs to provide their data to the application managed by the cloud provider. So, for example, Microsoft Office 365 provides a fully working version of MS Office that runs in the cloud. All you need to do is create your content, and Office 365 takes care of everything else. So, I know that that was a lot of information to understand, so I'm just going to summarize it. Basically, infrastructure as a service is the most flexible category of cloud services. It aims to give you complete control over the hardware that runs your application. And instead of buying hardware with IaaS, you rent it. Platform as a service also provides the same benefits and considerations as IaaS, but of course, there are some additional benefits as well. However, one thing to note is that there can be some limitations to a cloud platform that might affect how the application runs. So, just as a pro tip, when you're evaluating which platform as a service platform is best suited for your workload, be sure to consider any limitations in this area. And just to rehash, software as a service is software that's centrally hosted and managed for you and your users or customers. Usually, one version of the application is used for all customers, and it's licensed through a monthly or annual subscription. Software as a service essentially provides the same benefits again as IaaS, but there are some additional benefits as well. In terms of disadvantages, there can be limitations to a software application just as platform as a service that you might not or that might affect how the users work. So because you're using as is software, you don't have direct control of features. So once again, when evaluating which software as a service platform is best suited for your workload, just be sure to consider any business needs and software limitations. We can go to the next slide. There's actually a slide before that, rather.
Oh, yeah, I think
Yep.
it just glitched. Yeah.
Okay. Can you go to the pyramid one?
Yeah.
That one. Okay, awesome. So this picture summarizes the different cloud service models. I really like it because the pyramid shape shows you that as you go up the pyramid, limitations start to increase, right? Because going from infrastructure as a service to software as a service means that you, as the developer or the cloud tenant, have to worry about less and less things because more and more of those things are getting taken care of by the cloud service provider. But since they are now taken care of by the provider, you have lesser flexibility with them. So going up essentially means worrying less, but also having less control due to stricter requirements and parameters. So this is always a nice picture to have in mind when you're starting a business and trying to determine what kind of a cloud service model you need. We can go to the next slide. So before we end our discussion here of cloud service models, let us quickly take a look at what serverless computing is. So next slide. Yep. Okay. So what exactly is serverless computing, right? So like platform as a service, serverless computing enables developers to build applications faster by eliminating the need for them to manage infrastructure. With serverless applications, the cloud service provider automatically provisions, scales, and manages the infrastructure required to run the code. Serverless architectures are highly scalable and they are event driven, and they only use resources when a specific function or trigger event occurs. Now, it's important to note that servers are still running the code. The serverless name comes from the fact that the tasks associated with infrastructure provisioning and management are invisible to you as the developer. This approach essentially enables developers to increase their focus on the business logic and deliver more value to the core of the business. Serverless computing helps teams increase their productivity and bring products to the market faster, and it allows organizations to better optimize resources and stay focused on innovation. So we can go to the next slide. Okay, so now that we have understood why cloud computing is important and also what the different types of cloud service models are, let us quickly recap all of this information. So as an overview, this image shows how the spectrum gets wider when you go from infrastructure as a service to software as a service, showing that the cloud service provider takes care of more and more things as you go from left to right. So infrastructure as a service is like a physical data center. It manages servers, networking, and storage. With platform as a service, the cloud service provider manages the operating systems as well as the database management and the development tools. And with software as a service, you get full-fledged cloud-hosted applications managed by the cloud service provider, thus leaving very, very few things for you to worry about. Um, Next slide. Yep. So okay, so now we just need to learn about one more concept before we call ourselves the pros of cloud computing, and that is the different types of cloud computing. So we can go to the next slide. Yeah. So there are three deployment models for cloud computing. There's public cloud, private cloud, and hybrid cloud. Now, each deployment model has different aspects that you should consider as you migrate to the cloud. So let's take a look at all of them one by one. The first one is public cloud. Now, services in this cloud are offered over the public internet and they're available to anyone who wants to purchase them. Cloud resources such as servers and storage are owned and operated by a third party cloud service provider and are delivered over the internet. The second category is private cloud, which consists of computing resources which are used exclusively by users from one business or organization. A private cloud can be physically located at your organization's on-site, which is on-premises data center, or it can be hosted by a third-party service provider. The last category is hybrid cloud. A hybrid cloud is kind of like a computing environment that combines a public cloud as well as a private cloud by allowing data and applications to be shared between them. So essentially, the key thing to remember or your takeaway from this slide should be that as your resources move from on-premises to off-premises, your costs are reduced and your administration requirements decrease. So now I'm going to hand it over to Radha.
Yeah, so thank you for the great introduction about cloud computing. And so now that we've understood what cloud computing is, we can get into Azure. So, what is Azure? You might have come to this presentation asking yourselves that. And it has definitely become a buzzword with the rise of more companies switching to online platforms. So, Azure is essentially a cloud computing platform with an ever expanding set of services to help you build solutions to meet your business goals. So, Azure services range from simple web services, such as hosting your business presence in the cloud, to running fully virtualized computers for whatever you want to do, whether it's like custom software solutions. And so, Azure provides several cloud-based services like remote storage, database hosting, and centralized account management. It also offers cutting-edge capabilities such as artificial intelligence and Internet of Things. Instead of maintaining CPUs and storage in your data center, you can essentially rent them for the time that you need them. And so the cloud provider takes care of maintaining all of the underlying infrastructure for you. The cloud essentially enables you to quickly solve your toughest business problems and bring cutting edge solutions to your users. And so basically, I'm going to get into a little bit of how Azure works. This video is pretty technical, so I'm going to break it down after that.
Hi, I'm Christina Warren, Senior Cloud Developer Advocate, and today we're going to be talking about Microsoft Azure, which is a private and public cloud platform. If you've used Azure, you're familiar with the services it provides to developers and IT administrators to build, deploy, and manage applications. So whether you're already a pro or you're just getting started, let's take a quick look at what happens behind the scenes. Okay, so Azure uses a technology known as virtualization. Virtualization separates the tight coupling between a computer's hardware and its operating system using an abstraction layer called a hypervisor. And the hypervisor emulates all the functions of a real computer and its CPU in a virtual machine. It can run multiple virtual machines at the same time, optimize the capacity of the abstracted hardware, and each virtual machine can run any compatible operating system, such as Windows or Linux. So Azure takes this virtualization technology and repeats it on a massive scale in Microsoft data centers throughout the world. Each data center has many racks filled with servers, and each server includes a hypervisor to run multiple virtual machines. A network switch provides connectivity to all of those servers, and one server in each rack runs a special piece of software called a fabric controller. Each fabric controller is connected to another special piece of software known as the orchestrator. So the orchestrator is responsible for managing everything that happens in Azure, including responding to user requests. And users make requests using the orchestrator's web API. The web API can be called by many tools, including the user interface of the Azure portal. So when a user makes a request to create a virtual machine, the orchestrator packages everything that's needed, takes the best server rack, and then sends the package and request to the fabric controller. Okay, so once the fabric controller has created the virtual machine, the user can connect to it. Azure makes it easy for developers and IT administrators to be agile when they build, deploy, and manage their applications and services. In fact, building a virtual machine is just the beginning with Azure's ever-expanding set of cloud services to help you meet your business challenges. It gives you the freedom to build, manage, and deploy applications on a massive global network using your favorite tools and frameworks.
Right. So let me quickly explain that. So how exactly does Azure work? So we saw her talk a little bit about virtualization. And so essentially what this means is that Azure uses an abstraction layer called a hypervisor to separate the tight coupling between a computer's hardware and its operating system. And so Azure essentially takes this virtual technology and expands it across all of the Microsoft data centers around the world. And each data center has racks filled with servers, and each server runs multiple virtual machines. There is essentially a network switch that connects all of the servers together. And so this allows for increased scalability. And so let me get into a little bit more of the details. So here I've provided a diagram that sort of shows how it works. And so one server in each rack runs a software called a fabric controller. And so fabric controllers essentially store, deliver, and monitor virtual machines in Azure. Each fabric controller connects to an orchestrator. And so an orchestrator basically manages everything that has to do with Azure. And so the user makes requests using the orchestrator's web API. So when a user makes a request to create a virtual machine, the orchestrator packages everything that's needed, picks a server rack, and then sends the package and request to the fabric controller. Once the fabric controller has created the virtual machine, the user can connect to it. And so Azure makes it easy for developers to be agile when they build, deploy, and manage their applications and services. And so I'll hand it off to Dakshika to talk about Azure services.
Yep, and we can go to the next slide. So we have all realized by now that Azure essentially helps you tackle tough business challenges. What you need to bring is your requirements, creativity, and favorite software development tools. And Azure brings a massive global infrastructure that is always available for you to build your applications on. So on the next slide, there is a video which gives us a brief introduction to the different types of services offered by Azure. And Radha, you can go ahead and play it now.
In this video, you'll see a general overview of what you can do in Microsoft Azure. Azure is a little word for some pretty complex and vast capabilities. So to keep things simple, let's break them down into 8 main categories: compute services, cloud storage, networking, app hosting, AI, IoT, integration, and security. Ready? Let's go. Compute services. These cover virtual machines, containers, and serverless computing, including microservices. These services are primarily for performing calculations, executing logic, and running applications. Cloud storage. This includes disks attached to virtual machines, as well as more structured formats such as file shares or databases, all of which can expand and shrink as necessary. Networking features. These features let you set up private network connections to your on-premises environments and configure and control traffic into and out of Azure efficiently, helping to optimize application performance and scalability. Azure App Host. This feature lets you run your entire web application on a managed platform in Windows or Linux. Plus, the Azure Marketplace has a huge range of third-party products you can run in Azure, including SAP and SQL database solutions. AI, including machine learning and pre-built cognitive services. These services help you search and analyze existing data to forecast future behaviors, outcomes, and trends. Those predictions can even be used to make apps and devices smarter. IoT. Azure enables you to integrate sensors and devices and manage them with IoT hubs, allowing you to create full-featured dashboards and apps to monitor and control all of your assets. Integration. Logic Apps and Service Bus connect applications and services and allow for workflows to orchestrate business processes, whether those connected systems are on premises or in the cloud. And finally, security. Security is integrated into every aspect of Azure, including a hardened infrastructure and global security intelligence monitoring. With Azure's identity management, you have tight control over who has access to each service and the data in it. That's a long list, and these 8 categories represent just a small fraction of the services available in Azure. Fortunately, it's quick and easy to try out a new service, then mix and match them to get exactly what you need. And the best part, you will only pay for what you use.
Great. So let's move to the next slide.
In this
Okay.
video,
All right, so like we saw in the video, Azure provides a variety of services, and in order for you to become an Azure Pro, you should have a decent understanding of the different types of things that you can accomplish with Azure. So let's get started. So the first category that you can see is that of compute services. Now, these are often one of the primary reasons why companies actually move to the Azure platform. Azure essentially provides a range of options for hosting applications and services. And some examples of compute services in Azure include Azure Virtual Machines, Azure Kubernetes Service, Azure Container Instances, and many more. Next, so linking compute resources and providing access to applications is the key function of Azure networking. Networking functionality in Azure includes a range of options to kind of connect the outside world to services and features in the global Azure data centers. Some examples of networking services in Azure include the Azure Load Balancer, Azure Domain Name System, Azure Firewall for security, and many more. For storage, Azure provides four main types of storage devices. Azure Blob Storage is a storage service for very large objects such as video files or bitmaps. Azure File Storage essentially allows file shares that can be accessed and managed like a file server. Azure Queue Storage is like a data store for queuing and reliably delivering messages between applications. And Azure Table Storage is a service that stores non-relational structured data in the cloud, providing a key attribute store with a schema-less design. Now, some common characteristics which are shared by all of these services are that they are durable and highly available with redundancy and replication. They are secure through automatic encryption and role-based access control. They are scalable with virtually unlimited storage. They are managed, handling maintenance and any critical problems for you. And lastly, they are accessible from literally anywhere in the world over HTTP and HTTPS. So Azure includes first-class support to build and host web apps and HTTP-based web services. For example, with Azure App Service, you can quickly create powerful cloud-based web apps. With Azure API management, you can publish APIs to developers, partners, and employees securely and at scale. The internet allows any item that is online capable to access valuable information. This ability for devices to garner and then relay information for data analysis is referred to as the Internet of Things or IoT. Now, many services can assist and drive end-to-end solutions for IoT in Azure. Examples of this include IoT Central, Azure IoT Hub, and IoT Edge. When we talk about big data, we are referring to large volumes of data. Data from many scenarios can generate hundreds of gigabytes of data. And this amount of data makes it hard to analyze and make decisions. It's often so large that traditional forms of processing and analysis are no longer appropriate. So examples of Azure services that help with this include Azure HD Insight and Azure Databricks. We can go to the next slide. Um,
Yeah, it's there.
Oh, okay. Yeah. So with Azure, developers can create mobile backend services for iOS, Android, and Windows apps really quickly and easily. And the features of the service include offline data synchronization, connectivity to on-premises data, broadcasting push notifications, and auto scaling to match business needs. Azure provides multiple database services to store a variety of data types and volumes. And with global connectivity, this data is available to users instantly. Examples again of Azure services based on databases include the Azure SQL database, as well as Azure databases for MySQL, PostgreSQL, and MariaDB. AI in the context of cloud computing, we're looking at the right side of the slide now, is based around a broad range of services, the core of which is machine learning. Some of the most common AI and machine learning service types in Azure are Azure Machine Learning Service and Azure ML Studio. Also, Azure also provides pre-built APIs, which are known as cognitive services. So you can use the Vision API, for example, for image processing, the Speech API for audio recognition, the Knowledge Mapping API for semantic searches, the Natural Language Processing API to evaluate sentiment, and Bing Search to comb billions of web pages, images, and videos and news with a single API call. Lastly, DevOps brings together people, processes, and technology by automating software delivery to provide continuous value to your users. With Azure DevOps, for example, you can create, build, and release pipelines that provide continuous integration, delivery, and deployment for your applications. You can integrate repositories and application tests. You can perform application monitoring. You can work with build artifacts. You can also work with and backlog items for tracking, automate infrastructure deployment, and integrate a range of third-party tools and services such as Jenkins and Chef. So all of these functions and many more are closely integrated with Azure to allow for consistent, repeatable deployments for your applications to provide streamlined build and release processes. So that was it about the different Azure services, and now I'm going to hand it over to Radha.
Yeah, so I'm going to speak a lot about the core Azure architectural components. And so here on this slide, let's start with resources. So essentially, resources are instances of services that you create, like virtual machines, storage, or SQL databases. Resources are combined into resource groups. And so these resource groups acts as logical containers into which Azure resources like web apps, databases, and storage accounts are deployed and managed. A subscription groups together user accounts and the resources that have been created by those user accounts. For each subscription, there are limits or quotas on the amount of resources that you can create and use. Organizations can use subscriptions to manage costs and the resources that are created by teams or projects. Finally, we get to the top, management groups. These groups help you manage access, policy, and compliance for multiple subscriptions. All subscriptions in a managed group automatically inherit the conditions applied to the management group. So here you can just see the entirety of how Azure is organized. And so let's get a little bit into Azure Resource Manager. I'm going to play a video and explain.
Azure Resource Manager has several features that you can use to organize resources, enforce standards, and protect your critical Azure resources from accidental deletion. Resource groups are containers for resources deployed on Azure. By placing resources of similar usage, type, or location in the same resource group, you can provide some order and organization to your Azure resources. Tags allow you to improve the organization of your resources even further. You can use tags to associate custom details with a resource or resource group, such as a cost center or billing department. Resource groups and tags are great for helping you organize existing resources or groups. But how do you make sure that new resources follow the same rules? You can use Azure policies to ensure that new resources use the same tags as existing resources, keeping things organized. How do you protect your resources once they've been deployed? Role-based access control provides fine-grained access management for your Azure resources, allowing you to grant users the specific rights they need to perform their jobs. IT personnel can manage settings. Developers can have read-only access, and administrators can have complete control all at the same time. You can even prevent resources from being deleted accidentally. By enabling resource locks, you can block the ability to delete a resource or prevent changes to it by marking it as read-only. Azure Resource Manager provides you with the tools you need to keep your resources organized and secure.
So let me get into Azure resource. So as the video stated, Azure Resource Manager has several features that you can use to organize resources, enforce standards, and protect your critical Azure resources from accidental deletion. Resource groups are containers for resources deployed on Azure. And so by placing resources of similar usage, type, or location in the same resource group, you can provide some order and organization to your Azure resources. And so a few features that I wanted to highlight were role-based access control and resource locks, which help to ensure the safety and security of the projects that you will be working on. And so here's just a little diagram that I've provided to sort of illustrate Azure Resource Manager. And so let me get into Azure regions. So a region for Azure is a geographical area on the planet that contains at least one, but potentially multiple data centers that are nearby and networked together with a low latency network. Azure intelligently assigns and controls the resources within each region in order to ensure that workloads are balanced. And so this goes back to my earlier point. Azure has more global regions than any other cloud provider. These regions give you the flexibility to bring applications closer to your users no matter where they are. Global regions also provide greater scalability and redundancy, and they also preserve data residency for your services. And so one thing I'd like to highlight is that Azure has availability zones across the US and across several regions in China as well. And you can see that Azure regions are scattered all over the world here too. And so basically, each Azure region is always paired with another region within the same geography, at least 300 miles away. And so this approach allows for the replication of resources such as virtual machine storage across a geography. And so this reduces the likelihood of interruptions because of events such as natural disasters, civil unrest, power outages, or even like physical network damages that affect both regions at once. For example, if a region in a pair was affected by a natural disaster, then services would automatically fail over to the other region in the region pair. And so some of the advantages of Azure structuring this region pair system is that if like an extensive Azure outage occurs, one region out of every region pair is prioritized to make sure at least one is restored as quickly as possible for applications hosted in the region pair. And so planned Azure updates are actually rolled out to pair regions one region at a time in order to minimize downtime and the risk of outage. So I thought that was pretty cool. And so let me get into a second topic, which is availability zones. And so availability zones are essentially physically separate data centers within an Azure region. And so each availability zone is made up of one or more data centers equipped with independent power, cooling, and networking. And so an availability zone is set up to be an isolation boundary. And what this means is that if one zone goes down, the other one continues working. And so availability zones are connected through high-speed power private fiber optic networks. And so that ensures the speed and access of information. And so we just wanted to talk a little bit about getting started with Azure. And so I'll hand that off to Dakshika.
Awesome. So now that we've learned all about cloud computing and the wonderful things that you can, get accomplished with Azure, let's just cut to the chase and start using Azure right away, right? So for one last time, just to convince you why you should move to Azure. So remember that with Azure, you are only billed for what you use. This means that companies do not waste resources like money thanks to Azure's pay-as-you-use structure. For students, this means that they can upgrade their existing subscription or get another one depending on whether they would like to use more space for building and deploying virtual machines. Once again, the cloud provider takes care of the underlying mechanics for you, and other tools like speech recognition and analytics that make Azure unique can give companies and individuals an edge over their competitors. So we can go to the next slide.
Yeah, it's
Awesome.
there.
So, yep. So what are you waiting for? Just go ahead and get started with Azure for free. You can sign up for a free account on the Azure website and start exploring the various Azure services at literally no cost to you. And just to kind of reiterate, your free Azure account includes free access to popular Azure products for 12 months, credit to spend on the first 30 days, and access to more than 25 products that are always free. So get started and explore Azure right away. And that is literally it for the presentation and the event that we had organized today. Thank you so much to everyone that attended. And you all are free to go now. If you have any questions, you can stay back and ask. But other than that, thank you so much.
Yeah, thank you guys so much. And as she mentioned, please feel free to stay back and ask some questions.
Of course, you're welcome, everyone.
Hi. So I just have a question about a project that we're working on at my company. It's basically using React and Spring. It's going to be something similar to MIT Scratch, but we're going to be using it as a recruitment tool. They want us to have CI/CD as well, right? So would that just be Dev Test Labs and DevOps for Azure, or is there anything else I should look into?
I think that's it. What do you think, Dakshika?
No, I personally think the same. Like for CI/CD and stuff like that, like DevOps is what plays a major role, right? So Azure DevOps, Dev Test Labs, that should be your go-to for that.
Okay, great. Thanks.
Yeah, of course.
Of course.
I wanted to ask you that I am actually very much new to Azure. Can you give me a starting material from where I should start learning about this?
Yeah. So let me see. Radha, is the Microsoft Learn accessible to everyone?
I wasn't sure if that's only for ambassadors. So I was just gonna suggest like starting on YouTube, and then I can go and check and make sure and see if there's like any resources that are accessible for general public. And if you just drop your email in the chat, I'll be sure to reach out to you and send you a few resources.
Sure, thank you.
What's your opinion on getting the certifications directly from Azure? Are they useful, especially in terms of career progression, or do you feel like they're useless? It's more about having the experience.
So I mean, I think that it's definitely a useful skill to have. It's like I know some companies even do certification, so you might want to look into like if your specific company offers it. And so, one thing I do encourage is to maybe like try to find like resources to sort of understand Azure like beforehand, sort of get familiar with like all of the concepts. I know today we were able to provide you with like a very high level overview, but being able to delve into it a little bit more, getting sort of like, I guess, informal experience definitely helps a lot as well.
Okay, so it's more about the experience, and the certification isn't as useful.
I'm just a college student, but I will say that definitely getting the experience is useful, and I guess it does have to depend. It does depend on like career stuff and stuff like that. So if like maybe you want to like talk to someone who works in your field and get like an opinion on that, that might help. Dakshika, do you have any thing to add to that?
No, not really. I think you explained it pretty well. Just one thing real quick for Debashri, you asked about learning Azure. I just found one resource that you can get started with,
Yes.
but it's just
Oh,
one. So I posted in the chat.
okay. So overall, like different resources online should be helpful enough to get a base of it.
Yep, that should be good. Maybe there should be a W3 Schools article on it. If not, like tutorials point or something. And
Hmm.
otherwise, YouTube is always a great way to
Yes,
learn.
yes, of course, of course. Thank you so much.
Yeah, of course. Thank you for attending.
Anyone else have any questions?
Hi, yes. Hi, thank you so much for this awesome workshop. I do have a quick question, and it's a little technical, and it's just because I'm very new to cloud computing. But earlier you talked about virtual machine. Could you talk a little bit more about why would a business want to use a mini virtual machine? Because I've used a virtual machine on my like computer, but I never really thought of it as like cloud computing or even businesses using them?
So essentially, businesses would want to use more virtual machines when they get a lot of traffic hitting their website or whatever app it is that is deployed on Azure, right? So you can use like load balancers and stuff. So when there's like just one virtual machine, there's just one instance running of it, and there's a lot of traffic hitting that one instance, so it might cause delays. But when you have multiple instances, that's when you can like distribute the load and distribute the traffic and send it to different VMs, which you know, will make your application more efficient and faster.
Great, that makes sense. So then in terms of servers, because I thought servers were also there to like have a lot of traffic so it wouldn't die or something. So do server and virtual machine, do they like work with each other, or is it like completely different things in terms of cloud computing?
Mm, I think so. From my experience, I think they should be working together, but I don't know how much of a difference there is. Radha, do you want to add to that?
I will say, like, one thing I wanted to add on to like the previous question was like virtual machines also, like, the reason like a lot of companies use a bunch of virtual machines is that they provide basically a lot of backup and storage for your data. And so this just goes back into the concept of like disaster recovery and stuff like that. Regarding your second question, could you repeat it? I wasn't sure if I got
Yeah.
it the first time.
Yeah, so I know many companies use servers to like store data, and also servers on the cloud is great. But I am personally confused on like the difference on the purpose between the virtual machine and the server in terms of cloud computing and traffic.
So I think with virtual machines, I guess it might just be like they have slightly different like purposes. I know with the virtual machine, one of the things like for instance I would be able to do is if I'm on a Mac and if I want to use like Power BI, which is exclusively a Windows software, then I can log in using a virtual machine and essentially access Power BI like that as if I was on like a Windows OS, even though I'm on a Mac. And I'm not really sure if you would be able to do the same thing with a server. And so it's just like I would say differences like that. Yeah, Dakshika, do you have anything you want to add to that, or is that like basically what you were thinking too?
Yeah, no, I agree. And virtual machines are kind of like a subcategory of virtual servers, right? So if you just consider server in general, so it can be like a physical server, right, which can be located like on premises or like at a data center. But your virtual machine is something that's on the cloud, so then it provides like additional benefits that we discussed in this presentation. So virtual machines essentially come under the subcategory of, or like under the broader umbrella of virtual servers.
Great. Sweet. Thank you so much.
Of
Yeah,
course.
of course. Awesome. Well, I think rather we can go ahead and close off the event now.
Yeah, I think so. Let me stop the recording just so, just in case.
Yep, sounds good.